Okay, let's read over this first Regents question here, guys. You know the difference between linear and not linear is going to have what characteristic? Well, if you don't have the equation, you have the data, right? What is the characteristic of a linear function? Constant rate of change, either adding or subtracting, right? If it's exponential, it's going up by some or down by some multiple, right? Okay, so read over the first one.
Wait, linear is the same, like the same rate of change, and then exponential is like not?
Correct.
Yeah.
Right, exponential, you won't be adding or subtracting the same amount. You'll be multiplying by the same amount. Okay? That's that multiple, that b. Because linear is adding or subtracting the same amount, constant rate of change. So what do you think in number one? Which one of those could be linear? Which one would have a constant rate of change? Not be multiple. Well, 10% depreciates 10% each year, right? So it means 90% remains. So each year it's 90% of a smaller amount, right? So will that rate of change be the same? But let's try this one. What's 90% of 100? 90, right? And then now do 90% of 90. 0.9, do 0.9 times 90.
90% 90?
Yeah. Okay, so not quite the same difference, right? And then do 0.9 times 81. So you're subtracting a different amount each time, right? So it's not linear. That's, oh, I keep doing that. It's that, it does that, right? So that's a, what? I don't even know. What is this? Good grief. So this one is exponential decay, right? Oh, hi, Mr. Miller.
I can't see.
We do not. There you go.
There.
Thank you.
Yeah.
Which way?
Yeah, you
Oh,
can
he
see
flipped
four.
it the wrong, yeah. Yeah. So which one, guys?
Four.
Amount of caffeine decreases by 1/3 every, so you subtract the same amount each time in number 4?
130.
It's got to be 3, right?
Yeah.
It goes down by how much every time, every day? 2, the same amount. Subtracts the same amount each time, right? That is our constant rate of change. Right? So choice 3. Well, the other ones are exponential, right? The fish doubles, right? If you start with 1 fish and double it, you got 2. Okay, you added 1, right? And if you double the 2, you got 4. Well, now you added 2. You double the 4, you get 8. Now you added 4, right? You're adding a different amount every time. Okay, on to number 2. So now we have a table. Same kind of questions, right? So look at the table, right? It might help to maybe jot something down off to the side here, right? So what do you think? Exponential growth, linear? How? It's so, let's check if it's linear. One, it would be +2, right?
Yeah.
And then +7, all right, linear's blown, right? Right? Or +6, yeah. So what is it then? How do you get from 1 to 3 if you're not adding 2? Times 3. How about from 3 to 9?
Times 3.
And then, so what is it? Which exponential though? It's growth, right? Because 3 is greater than 1. There you go.
Just circle the table.
What did I do that for? Growth. There we go. All right, 3. These are starting to look about the same, aren't they?
Yeah.
Which one of these would be linear?
A 3.
Yeah, 3. You add 50 people, the same amount, 50, every 30 minutes. Everything else is a multiple.
Hannah, what did you say? What is someone hiding?
It's
So it's
a
gonna be more than 50.
contingency not included in the problem.
Okay.
Yeah.
Hashtag everybody.
All right, let's go number 4. So these are quick and easy, man. Not bad, right? Number 4.
I can't do this now.
Check and see if it's linear or exponential.
So it's adding 87. Wait, what?
Well, if you think it's adding like 87, you need to check all of them, don't you? Not just one of them, right? Because it has, if, you know, one of them's 87 being added, they all have to be linear, yes? And if it's not, it can't be linear. Huh? It's not linear? Is it linear?
Yes.
Oh, we better settle the debate, huh?
I don't know.
435 and 87.
Oh,
Yeah, it's linear.
Yeah,
Because
okay.
it's just negative 87.
Inputs, outputs. How do you get from do 435 minus 348? See what you added. And then do 522 minus 435. Is it always plus 87 for all of them?
Yeah. That's linear plus 87. Or just do 348 plus 87.
So like if you saw this one on a test, right, this would be like the work you'd show, right, what I just did here, right? Okay. So what's our answer?
Linear.
Linear. Okay. Now, hey, by the way, was it?
It's a constant.
Okay, there's a constant rate of change of 87. Good. It has a constant rate of change of 87, right? You can't just state linear and be done with it, right? Because it said justify.
Yeah.
With me? You gotta show where you determine it's 87, right, and then state it. Okay? On to the next page, number 5.
The first one's linear. Because you're adding 5.
Yeah, just think to yourself for a minute. What do you- Go. I mean, read the problem, obviously, first, right?
This is so easy.
I want to know which one represents a linear model. Why?
Because you're adding 5. And then in number 2, you're adding 7. And then you're adding 13. And then you're adding 5.
Plus 7 plus 13, right out of the gate, that can't be right. And similarly for the other two, right?
Yeah.
You're adding and subtracting different amounts each time. Okay, so not a constant rate of
That
change.
was the hardest one.
Oh, that's a shame. 6. 3 situations here. Which of those, maybe one or more than one,
2
exponential?
2 and 3. Yeah.
Let's look at number 1. Would choice 1 be exponential? The bacteria doubles every day?
Yeah.
That's exponential. That's a multiple, right? Right? So this is exponential. How about choice 2?
That's just a linear one because
Because,
it's one.
Because you're growing an egg.
what's the phrase I'm looking for?
It has a constant rate.
It has a constant rate of change, 1 inch every day, right? What about choice 3?
It has a percent in it because obviously it declines by 5%.
So that's exponential
Exponential right there.
decay, right? So what's our answer?
2. Number 2.
You mean choice
No,
3?
it's 4.
Or, yeah, 4. 1 and 3?
It says exponential function.
Ah, you thought it meant linear, huh?
Yeah.
It said exponential. Okay, last one. See a key word in there?
It's
Not a linear function, and 4 has say that again. Not a linear function.
Somebody said a linear.
Oh, that's not the last one, sorry. Which one is it?
It's 4 because it has a percentage in it. It depreciates 50%.
So this looks like a constant rate of change, or this 10 actually. And that's a constant rate of change. That's a constant rate of change, so that's
And
exponential.
it says depreciates 50% every year.
Yeah. Now we're on the last one.
This is an exponential growth.
Because it's.
Well, why don't you read the problem, see what they're asking?
Is Caleb correct?
I don't know, what did he
I
say?
don't know how.
That's not
Yeah,
where the
I
problem
guess.
starts.
You multiply by. It doesn't. Caleb
What?
claims that the word pairs shown.
Yeah, why didn't you read that first?
Are from a nonlinear
Why do
function.
you guys do that? You read
Yes,
something starting in the middle.
Yes,
Why?
because.
You
Because
multiply
it's.
by 2.
No, I'm asking why you started reading
Yes,
here.
it's not a.
Look, I'm asking a different question. Why does everybody start reading here
Because.
and not up here?
Because up there blended in with the other question.
Yeah, I was confused. But then
See,
I was like,
8,
oh.
Yeah, Mr. Heffner, I see where you're coming from, but I feel like I was also very accurate.
I don't understand.
yeah, but you didn't even know what the question was.
It Caleb's.
Is he correct? Is it non-linear?
It's not linear because it's multiplying by, it's going up, it's doubling every time.
Yeah, it's doubling, right? Or you could say, well, this is plus 2, and then what? Plus 4 plus 8, right? Okay, so is he correct?
Yeah.
He's correct. Why?
Because it's not constant.
It does not have a constant rate of change. It does not have a constant rate of change.
I just said yes, and it's doubling.
Yeah, I think that's probably fine. You probably are safer using the constant rate of change. That's kind of a theme, that term, right? I think you'd be okay, but probably better to stick with this. Okay? Good with these?